Then we would now continue with the next presentation. And for this, I invite Giovanni, Paolini, and Ainhoa Movilla with us here in Bonn, and they worked on a project with the title Wildfire Emissions Explorer. They are ECMWF mentors for Mark Parrington, Miha Ratzinger, and Sebastian Garrigues. And Mark is also with us today, and he will share with us first the motivation behind the project, and then Giovanni and Ainhoa will share what they've been working on.
Okay, thanks. Yep. So my name is Mark Parrington. I'm a senior scientist in the team that delivers the Copernicus Atmosphere Monitoring Service, and I work on atmospheric composition, atmospheric pollution, and wildfire emissions. So I'll give a little bit of a background as to how we do that, why we do that, and that leads then nicely into what Ainhoa will show for what they developed over the last few months. Okay, so I should acknowledge my fellow mentors. So James, you've already seen today, and Miha Ratzinger and Sebastian, who are hopefully viewing online, who are based in Reading still. So what I'm going to show you I'll skip the backgrounds. You can read that. I'll come back to it at the end. So essentially what we're doing in the Copernicus Atmosphere Monitoring Service is running forecasts of atmospheric pollution globally, similar to a weather forecast, but it's atmospheric pollutants. And so, for example, smoke from wildfires, desert dust, and things like this. And it's all based on Earth observation data. So we're simulating all the weather parameters like we do for the weather forecast, but on top of that, we're adding satellite observations of different atmospheric constituents. And for fires, we're using satellite observations to estimate, to provide information on the location and the intensity of the fires. And from that, we can estimate emissions of different pollutants. And so this is really a key input for being able to predict atmospheric pollution and smoke transport. This is an animation that was nicely produced by Sylvia at the back there, and we've used for our communications.
It's Summer of Code 2019.
Summer of Code, okay, all right, okay. So excuse me. So yeah, so another link. Anyway, this I'll just start it again, but I won't let it finish. And so this is giving you a sense of the day-to-day variability of global wildfires. We see tropical Africa in the tropics, lots of fire, and then if you noticed in the summer, the snow retreats and the ice retreats, and we get fires in the boreal region as well. Okay, without going into any more technical detail. So this is just an example of a recent case. So in the summer, it's the dry season in South America. There's a lot of fires across the Amazon region. There's a number of reasons for why that happens and the scale of them. So this is just, without going into the details, on the left is a map of what the output from our GFAS system looks like. The red dots are the location. And then we can break this down into these time series of daily fire rated power. So this is the intensity comparing this year in red with an average, a climatology of the previous 20 years in gray, and also then total estimated emissions. And then this is just to show this animation showing aerosol optical depth. And basically you see all these dark red values. This is smoke coming from these fires. We see it spreads out over a large region, and down at the bottom, we have confidence in this because we can compare with independent measurements. And then this shows that we catch these peaks and the magnitude very well. This is a long way of getting to the bottom line. Basically, these plots in the middle have all over the last 5-6 years been produced by me by hand using IDL, which is proprietary software and very unwieldy and very I do it day by day, partly because it's my job and I'm interested, but we want to have this more flexible. And so those kind of charts have been used for our communication activities in CAMS very successfully, I would say, over the last few years. We've really built up a big profile, not just for fires, but for other atmosphere monitoring based on the back of these bar charts. So I never imagined in my wildest dreams that plots and bar charts would be successful in social media, but there you go. So there's some examples here. So some things on Twitter. These feed into web articles and information that we give to the media and the press. So there's 2 examples here, and also information that goes into the C3S European State of the Climate report every year. So these are widely used and really crucial to some of our communication activities. We also produce these in near real time, so we can understand straight away fires anywhere in the world, the scale, the magnitude, how that relates to how unusual it could be. And then this is just to then show the success of those communications. So on the left, this is a chart just from July 2019, where our communication really took off with fires in the high latitudes in the Arctic. These have never been seen in the last 20 years at least. And we see this is the number of media engagements through July. The United Nations made a press meeting around this time, showed our data, and it really took off. And then this is over the last 5 years, a sense of how much the global media uses CAM's data in its coverage. This is just related to wildfires. So, and this is the number of independent pieces of engagement and news articles that use our data. So these guys have done a great job. They produced a very nice tool that's, I understand, fits very well with developments for the climate and atmosphere data store. And so there's a real strong chance that we can use this directly in nearer time for our communication activities. And we can start adapting our monitoring, day-to-day monitoring and communication, and have it a bit more streamlined, a bit more operational, rather than me sitting for half an hour every morning, typing buttons to run IDL scripts. But I should leave the rest over to Ainhoa to show you what they've done. Okay, thanks.
Well, thank you for the introduction, Mark. I will be presenting the solution that we are going to propose, and then Giovanni will be ready to answer any questions that you may have. So, yeah. Well, you know the team. We already presented each other. We presented ourselves before, but it's Giovanni and me who carried out the project. As Mark mentioned, the idea of this goal of this project is to make data visualization more simple and more flexible for them. So for that, we used GFAS database from ECMWF, data set from ECMWF, delivered daily at 0.1 degrees from January 2003 to the present, and derived from the MODIS satellite data. So regarding the tools that we used for visualization, we used Python with the following packages. We used the Jupyter notebook for the creation of the structure of the UI. We used Voila to compile the notebook into an interactive UI. We used Leaflet to provide us with a map widget so that we could create a map that the user could interact with for the geographical selection that you will see later, and Matplotlib for the visualization. And for processing, we used the data were stored in a PostGIS database and were queried with the pandas and geopandas. So the GUI that we created has 5 different steps. The first one is the geographical selection for the user to select the area of interest, the period of interest, and the reference period in case you want to compare with your period of interest, and the different variables. You have to choose which one you want to plot, and the different plot types. And now we will show a GIF, well, GIF. In Spain we say GIF. Sorry. Yeah, with the UI. So it may go a bit fast. I will try to catch up. But so the first step is to choose the area of interest. So you can do it by, for example, selecting countries, using bounding boxes, creating polygons, selecting continents, and basically in the end you get a final shape when you merge everything together. And this shape, you can download a shape file in case you want to save it, and later on you can also upload your own file, shape file, if you want. You choose the specific period of interest, the reference period as well, and then the variable that you want to plot and the type of plots. So what we provide in here are line plots, bar plots, 2D plots, 2D visualizations of the area of interest, and 2D animations as well, time animations. So you can, on the one hand, you can download this CSV file in case you wanna plot it somewhere else, make a cooler plot that is more attractive for social media than what we see here. And you can also directly download also the plots that you create with this GUI.
Yes.
And apart from the UI, you can also use a configuration file that you can run from the terminal with the command line in the slide. So this helps to quickly iterate and generate more plots with a single configuration file. And you can, it's stored directly locally. So in this case, with this single configuration file, we are plotting 3 different plots, one for the region of Spain, Portugal, and Austria, a second plot for France, and a third plot for Italy, as an example. That's it. And for validation, we use the data from a press release regarding the wildfires in Alaska in June. So in this plot, we can see the wildfire radiative power for the month of this June in red, and the reference period in gray, which is the average of the months of June of the previous years. And we can see the same variable in a 2D visualization, and here you can see it small, but there's a small animation of how it evolved in June. And that's it, quick and short. Yeah.